Hello dear students, good morning. Welcome back to the chemistry class. In the last class just we have revised the part first of the solution topic on which we are going to conduct the first weekly test. So in today's session let us discuss the next concept, the continuation part, as we have completed two colligative properties in the previous sessions. In today's session, we will discuss the one more, the third colligative property, that is depression in freezing point. Please note the next heading, depression in freezing point. Depression in freezing point. Delta TF. The first one is relative lowering in vapor pressure, and the second one is elevation in boiling point, and this is the third one, a depression in freezing point. This is somewhat similar to elevation in boiling point. Both the concepts are similar. What is the formula for depression in freezing point? Depression in freezing point, elevation in boiling point. In the last class we have completed elevation in boiling point, that is delta TB is proportional to M. Delta TB is equals to KB into M, where delta TB is TB minus T naught B. So here TB is proportional to delta TB, that is proportional to concentration, and the molar mass of solute Mb is equals to Kb Wb 1000 divided by delta TB into WA to find the molar mass of solute, right? So this is the concept we have covered in the previous session, that is second colligative property. Now similar to that, so here first point we need to discuss about what is meant by this freezing point. What is the definition of the freezing point? So in the last case we have defined the boiling point. Boiling point is nothing but the temperature at which vapor pressure of a solutions which becomes equals to atmospheric pressure, that is called boiling point. So let us consider the graphical representation between the vapor pressure. So let's say this is a vapor pressure versus the temperature axis. I assume that this point will be atmospheric pressure. It is atmospheric pressure. So in last case we have considered this graph, vapor pressure versus temperature axis. Now if we are considering 2 points, so here one more frozen point, that is, so this is in solid phase, the vapor pressure of a substance in solid phase I am considering. Now somewhere boiling point at higher temperature, or we can consider 2 points at high temperature. So 2 points. Now this is say point A and this is point B. Can you predict the point A represent a solvent or solution? Yes, it is a solvent because its vapor pressure is more than B. Higher vapor pressure is for solvent, whereas lower vapor pressure is for solution. But at this temperature, when temperature decreases, its vapor pressure go on decreases, and at a particular temperature it reaches this frozen point. So this is for solvent. And similarly, for solutions also, the vapor pressure gradually decreases as the temperature decreases, and somewhere it reaches this point. Look at this. So this is pure solvent, and this is for solution. Solvent and solution. So this point is called as, the temperature corresponds to this point is known as, this is the freezing point. Freezing point. One is for solvent and other is for solution. Freezing point. So since this is for solvent, T naught F. T naught F. Look at this. So how to define this freezing point? Freezing point is nothing but, it is the temperature at which, a substance, whether it is in liquid phase or in solid phase, which having the same vapor pressure. The vapor pressure in solid phase and liquid phase for a substance is the same. That temperature is called as freezing temperature or freezing point. So freezing point can be defined as, it is the temperature at which a substance in both solid phase as well as in liquid phase will have the same vapor pressure. So the temperature at which the vapor pressure of a substance in solid phase as well as in liquid phase will have same vapor pressure. The temperature is called as freezing point. Hope the definition is clear. What is the definition of boiling point? Boiling point is nothing but it is the temperature at which the vapor pressure of a substance becomes equals to atmospheric pressure. So this is for solvent. So this point is boiling temperature of solvent. It is solvent. Whereas the point B, so this is the boiling temperature of solution. Is it clear? Yes. So this is the vapor pressure of a substance in solid phase. So this dotted solid line, solid line indicates that it is the vapor pressure of a substance in solid phase. Whereas this is the vapor pressure, the dotted line indicates the vapor pressure of the substance in liquid phase. So the temperature at which, this is the temperature at which a particular substance, solvent, the substance in both solid phase as well as in liquid phase will have the same vapor pressure. That temperature is called freezing point. If the vapor pressure becomes equal to atmospheric pressure, this is atmospheric pressure, then this temperature is called boiling temperature. Boiling point and freezing point. Definition is clear. Everything is remaining same as we have discussed in boiling point. What is meant by this depression in boiling point? That is a decrease in boiling point. So the decrease in freezing point. In boiling point, solvent having this boiling point, that is T naught B, whereas solution, the boiling point of solution is higher than that of solvent. The boiling point of solution is higher than solvent, whereas the freezing point of solution is lower than freezing point of solvent. Look at this, is the difference between elevation in boiling point, depression in freezing point. So this difference between the freezing point of solvent and solution is known as delta TF, depression in freezing point. The difference between the boiling point of solution and solvent is known as elevation in boiling point. In the previous sessions we have discussed that elevation in boiling point. So here delta TF is equals to, higher one is for solvent, T naught F minus TF, whereas in the previous case delta TB is equals to TB minus T naught B. So here if you want to calculate TF, that is freezing point of a solution, TF is equals to what happens? T naught F minus delta TF, whereas TB is equals to the boiling temperature of a solution is equals to delta TB plus T naught B. T naught B. Since T naught B and T naught F are constant, as the molality increases, that is concentration increases, these terms increases. Since we know that delta TB is proportional to M, similarly delta TF is also proportional to M. Delta TB and delta TF both are directly related with M, that is molality. So when concentration increases, this term increases. So when this increases, TB increases, whereas TF decreases. So therefore I can write TF is inversely proportional to delta TF. TF is inversely proportional to delta TF, whereas TB, boiling temperature of solution, is directly proportional to elevation in boiling point, that is depends upon concentration, molality, small m. Whereas in this case, delta TF is directly proportional to molality, hence TF is inversely proportional to molality. This is for the point of objectives. Right. Now, both with compared to elevation in boiling point, we have defined depression in freezing point. Now its definition is clear. Delta TF, how to define this? So it is the difference between freezing temperature of solvent and freezing temperature of solution. Delta TB definition is we have discussed. Now mathematically it is given by delta TF is equals to T naught F minus TF. Now it has been experimentally determined that so this delta TF is directly proportional to molality of the solution, similar to delta TB. In the last case, delta TB is proportional to M. If we remove the proportionality constant, delta TF is equals to KF into M. In the last case, delta TB is proportional to M, delta TB is equal to KB into M, where KB is nothing but elevation, molal elevation constant, or simply we can call ebullioscopic constant. So here this Kf is nothing but where this Kf is equals to depression in freezing point constant, depression, molal depression freezing point constant, or simply we can call cryoscopic constant, that is ebullioscopic constant, it is cryoscopic constant. Then what is the definition of this cryoscopic constant? It can be defined as Kf can be defined as Kf is equals to delta TF for molality is equals to 1. This is the definition. How to define this? So cryoscopic constant can be defined as it is the difference between freezing temperatures of solution and solvent. Freezing temperature of solution and solvent for 1 molal solution. Cryoscopic constant can be defined as it is the difference between the freezing temperature of solution and solvent for 1 molal solution is called as cryoscopic constant. There also we have defined same, Kb is equal to delta Tb for M is equals to 1. What is the unit of this? Its unit is same. Unit is same for both Kf and Kb. That is Kelvin, that is temperature per mole. Kelvin per mole, or we can call degree Celsius per mole. But the best unit is Kelvin Kg per mole. Kelvin Kg per mole. This is a common unit for both. Unit is same for both Kb and Kf. Both Kb and Kf. Now, molality. Continue. So here delta TF is equals to Kf into Molality. What's the definition of molality? Molality is defined as number of moles of solute present in 1 kg of solvent. 1 kg of solvent. If solvent is given in terms of grams, then multiply by 1000. NB is nothing but given mass divided by molar mass. Given mass divided by molar mass into 1000 divided by WA. Now I want to calculate MB. Therefore, MB is equals to KF WB into 1000 divided by delta TF delta TF into WA. This is the third formula to calculate molar mass from the third colligative property. Is it clear? Okay. This is the third one. Third formula. This is the second formula. First formula from RLVP, relative lowering in vapor pressure. Yes, it's clear. That's depression in freezing point. First point, the definition. What is meant by freezing point? It is the temperature at which a substance will have same vapor pressure in both solid as well as in liquid phase. That is called freezing temperature. And the difference between freezing temperature of solvent and solution is called as depression in freezing point. Mathematically, it is given by this formula. Experimentally, it has been found that delta TF is proportional to M, and further simplification, this is the formula to calculate the molar mass of solute. If Kf is not given, then we need to calculate Kf. It is similar to Kb. Kb is calculated by the formula MTR, right? MT square Kb divided by enthalpy of fusion. So enthalpy of vaporization, whereas Kf can be calculated by the formula, same formula, Mt square F, here it is freezing point, into R divided by, in place of delta H, enthalpy of vaporization, here we can take enthalpy of fusion into 1000. If Kb is not given, then we can calculate the Kb value by using this formula. So this is regarding the third colligative property, that is depression in freezing point. Right? In the next class, we will solve some of the numericals on depression in freezing point.